The Japanese company Kawasaki Robotics has developed one of the most advanced collaborative robots called Nexage. Nexage is a robot whose main task is to replace humans in monotonous work such as on the production line. According to the manufacturer, the robot can collaborate with humans, other machines, and use specialized tools. The robot's torso weighs only 29 kilograms, while its base is as heavy as 130 kilograms. As for its height, it is adjustable and can reach a maximum of 170 centimeters. Nexage is capable of lifting objects weighing up to 3 kilograms. The robot is designed to work in factories and other production lines. It can be controlled using a tablet with special software that can be quickly customized for specific tasks. Professor Hiroshi Ishiguro from Osaka University gained worldwide recognition in the field of robotics thanks to the ultra-realistic android robots he and his team created, with the most popular one being the robot Erica. Erica is a humanoid robot functioning due to a synthetic organism with an electronic brain system. The robot's body can have various organs of real humans, which are indistinguishable both in appearance and functionality from real ones. According to scientists, a gynoid is a humanoid robot woman, essentially the same as an android, but of the female gender. Creating a new android, Professor Ishiguro's team not only provided the robot with new eyes, ears, and other more realistic parts, but also equipped it with conversational capabilities. Despite all the efforts of roboticists, Erica still looks a bit wooden compared to living humans. However, the robot can engage in casual conversations on a range of simple topics and answer questions like, "What is your hobby?" Researchers recently announced plans to connect Erica to an artificial intelligence system, enabling her to freely converse on various topics. It's intriguing to wonder whether Erica will surpass the limits set by humans and potentially lead to a machine uprising after being connected to artificial intelligence. Engineers and designers from the University of Tokyo have developed a robotic backpack called Gai Arms, which allows connecting up to 6 mechanical arms. This device attaches to the torso using several straps, and the hands of the arms can be interchangeable. The user can choose between human-like hands and grippers. The robotic backpack weighs 4.1 kilograms without the robotic arms. When the robotic arms are connected, the weight of the device increases to 14 kilograms. The arm movements are controlled remotely using a special setup, which is a scaled-down replica of the device itself. Currently, controlling the arms through the robotic backpack presents certain challenges. Sometimes the cooperation of multiple operators is required, and it is impossible to use the device without the assistance of others. This is the main problem that needs to be solved. However, in the future, with the development of neural interfaces, it may be possible to achieve mind-controlled operation, allowing the user to control the robotic arms as if they were their own. Engineers at Toyota have developed a humanoid robot called THR-3. Since its creation, the robot has undergone numerous updates and improvements, significantly increasing its functional capabilities. The robot's movements are controlled by a human operator using the Master Maneuvering System module. The operator received tactile feedback, and the image transmitted from the robot displayed on a virtual reality headset HTC Vive. Special gloves and servo motors are also used, enabling the operator to control the robot instantly with precise movements and applied force. The robot demonstrates excellent balance, including the ability to stand on one leg and perform various movements. Toyota's robot stands at approximately 152 centimeters and weighs about 75 kilograms. While it serves as a test platform, the ideas and capabilities implemented in it can be used in devices for home use, medical facilities, construction sites, areas affected by natural disasters, and even space in the future. The Japanese robotics company Jinky has attracted significant attention with its unique heavy machinery, a humanoid industrial robot that can be remotely controlled by a human. The Jinky humanoid robot serves as an example of human-machine integration. The robot has a head, torso, and 2 arms that extend upward from a specialized cabin resembling an excavator's cockpit. Designed for technical maintenance tasks in various fields such as repairing railway tracks or replacing and repairing road signs, the robot can replace a team of workers, thereby reducing the risk of serious accidents in industrial settings. It is capable of lifting and moving heavy loads, such as steel pipes, plates, or wires, and performs its tasks as effectively as a human, as it is controlled by a human operator. Jinky essentially replicates the movements of a real person inside the heavy machinery cabin. The operator wears special glasses connected to the robot's eyes, allowing precise control of the robot's arm movements using technology developed by the company. Can you imagine how humanoid robots are landing in places affected by natural disasters, on a rescue mission, or where these robots take care of severely ill or elderly people? One of the few companies making significant advancements in this field is Kawasaki Heavy Industries, commonly known as Kawasaki. One of the company's most outstanding developments is the humanoid robot Kaleido, standing at 184 centimeters tall and weighing 85 kilograms. The robot is designed to work in dangerous areas, such as collapsed structures, fires, and natural disasters. Developers assure that in the future, it could operate at the ocean floor or even in space. Its humanoid form enables it to use the same tools as humans. Kaleido is durable and easy to repair, making it a very interesting and promising innovation. Why torture real horses when robots can be harnessed? Kawasaki recently showcased a robotic goat capable of jumping and carrying loads, officially unveiled at the 2022 International Robot Exhibition in Tokyo, which we covered in a separate video on our channel. BEX is an offshoot of the Kawasaki Kaleido program. In its regular mode, the robot is quite slow and clumsy, but in situations where speed matters and the route consists of smooth paved surfaces, BEX can lower its body and get on its knees with 4 pairs of wheels, one on each knee. As a result, the robo-goat transforms into a kind of electric scooter. BEX has a payload capacity of approximately 100 kilograms, so in addition to transporting heavy materials, it can carry human passengers who control the quadruped using a traditional pair of handlebars. THK Company has developed a very interesting exoskeleton operator. The robots mimic operators' movements with remarkable precision and smoothness, ensuring minimal response time. Upon the client's request, the company gives the robots a completely human-like appearance. The CDAR-7 robot assists in identifying quality issues in various technological products, checks cleaning results, and much more. It can also be remotely controlled when necessary. In the future, the company plans to improve the system so that it can make most decisions autonomously. Nachi Fujikoshi spot welding robots provide innovative production capabilities with incredible speed. Robot motion makes minimum cycle times unbeatable. Lightweight and high rigidity design results in high acceleration and minimum vibration. Maximum speed on all axes reduces move time. All this provides dramatically improved productivity. Observing them, it becomes evident that humans will soon be unnecessary in a variety of professions. In particular, welding tasks in automobile factories have long been taken over by robots. If you enjoyed the video, don't forget to like it and subscribe to the Karo Show channel. Also, check out our previous videos. See you next time.